This is 3.1, end behavior of polynomial functions. So first of all, we have your essential question. How do you determine the end behavior of a polynomial function? So, we have a few terms to go over. The blank of a polynomial is the term of the highest degree. The leading term of this polynomial is 5x cubed, so if you haven't figured out, it's the leading term. The leading term of a polynomial is the term of highest degree. Okay, so the degree is an important term that we'll talk about in just a second. The next one, the blank of a polynomial, is the coefficient of the leading term. That is the leading coefficient. The leading coefficient of a polynomial is the coefficient of the leading term. The leading coefficient of that polynomial, this one up here, is 5. It's because that's the coefficient, the number in front. And finally, the degree is the degree of the leading term. The degree of this polynomial is 3 because the degree is the exponent. Oh, that's a typo. I said the degree is the degree. The degree is the exponent of the leading term. There we go. So the exponent is that 3, so that's my degree. Example 1, name the degree and the leading coefficient and the constant term. Okay, so we need to find the highest, the degree is the highest power, so right here. So my leading term is 6x cubed. The leading coefficient is 6. The degree is 3. The power is 3. The number in front is 6. And it says the constant term. So that is the one without an x. So there it is. Positive 1. Actually, you should probably put positive 6. That's an important part. The sign is really important. Okay. Name the degree, the leading coefficient, and the constant term of this. Ooh, so hopefully you know how to multiply out different things. Okay, we don't want to multiply out the whole thing. We kind of want to look at the leading pieces. So what we're going to do is the highest degree of each part. Notice this is squared, so you got to take that into account. And I'm going to multiply them together. So 5x, 3x, 2x, and 2x again, because there's 2 of them. When I multiply all those together, I will get my leading term. So that's 15, 30, 60, positive 60, x to the 4th. So my leading coefficient is positive 60. My degree is 4. And the constant term, we do the same thing, but we do the ones without anything. Once again, it's squared, so I had to do that last one twice. So it's 1, negative 1, 5, 5. So the constant term would be negative 25. There we go. So notice you don't have to multiply the whole thing out, just the parts you need. The biggest exponent of each part is going to give you the leading term. Then one without an exponent with each part is going to give you the constant term. All right. Says the graph of the higher order polynomial function depends on several things. Using a graphing utility, we will explore the relationships between the function and its graph. Okay, so you're going to need something like Desmos to graph these out. So the first one, we're going to type that thing into Desmos and get the graph, and it's a rough sketch. So when we type this one into Desmos, we actually get something that looks kind of like this. It's a rough sketch, like I said. I'm not doing anything exact at all. Rough sketch. Okay. Then we can fill out the highest degree term here. So looking at this, its highest degree term is 3 positive 3x to the 4th. The coefficient is positive 3, so that's a positive coefficient. The degree is 4, so that's an even degree. Okay. And then we're going to talk about the end behavior each time. So I'm going to add in a little thing here that you want to write in, end behavior. That is what is happening at the ends of my graph. So I'm going up on both ends. So we call that up, up. Okay. Next one, I guess I'll write out this stuff first. So you're going to want to type this whole thing into Desmos. Y equals 2x to the fifth minus 5x squared minus x plus 2. In this case, my highest degree term is 2x to the fifth. Positive 2 is my leading coefficient, so it is positive again. 5 is my degree, so this time it's odd. And we'll notice something when we look at the graph. Kind of looks like this is, once again, really rough sketch, general shape. And so we look at the end behavior, which is this time down, up. So down, up. Notice I'm going left to right, leftmost, the left arrow, right arrow, basically. All right, next one, negative 2x to the fourth. So it's a negative 2 with a 4. So it's a negative coefficient with an even degree. And this time when we do the graph, you kind of get something like this. Once again, real rough sketch. And I get my end behavior. Which is down, down, right? My ends are both going down. Left side is down, right side is down. Okay, example 6. Look at the leading coefficient. It's negative x cubed. A lot of people get stuck. Well, what's my coefficient? Don't forget, there's a 1, right? Negative 1 is my leading coefficient, so it's negative. My degree is 3, so that's odd. Kind of looks like this. There we go. So I get my end behavior then is up, down. The end behavior, what's what we were just looking at, is kind of what we're talking about in this section. So the end behavior is what we're going to notice. So if we go back and look, if we had an even degree, hopefully you noticed this one was even, in example 5, and example 3, and when we had an even degree, the behaviors were the same. When it was a negative lead coefficient, they were both down. Positive lead coefficient, they were both up. So even is positive, up, up, negative, down, down. The degree, when it was odd, they had 1 in each direction. So that's example 4 and example 6. Notice when it was a positive lead, down, up, negative lead, up, down. This is something you want to have memorized, this end behavior table, because looking at the end behavior can tell us a lot about a graph. Okay, so we can look at this problem right here and say identify the end behavior. Well, right here, leading term is 3x to the fourth. Remember, it's the highest exponent, so be careful with that. They're not always in order. The lead coefficient is positive 3. The degree is 4, so it's a positive. And then even, so we would say up, up is the answer. Justify. We justify by making the graph. So you type this equation into Desmos, and you get something that looks kind of like that. And look, up, up. Done. Example 8, write a polynomial function with end behavior of, on the left, f of x goes to positive infinity. On the right, f of x goes to positive infinity. So positive infinity, we're talking about y values, right? F of x represents y values, so that is up, up. Okay, so I can write any equation as long as it's up, up. So y equals, or I guess we should name it the same, f of x, that's the name they gave us, equals. Has to be positive lead coefficient and even, right? Up, up is positive lead coefficient and even. So 7x to the 8th minus 3x cubed plus 2x squared minus 1. Doesn't matter what anything else is as long as the lead coefficient has a positive and the degree is even. Okay? And finally, sketch a graph of a polynomial function with a negative lead coefficient and an even degree. So negative lead, even degree is down, down. Done. Sketch a graph, down, down, done. Okay, so you have your summary, 3-sentence summary. You can write that out.